Hello everyone. In today's class, we are going to see the topic rectifiers. I am Radhakrishnan, Assistant Professor in the Department of Biomedical Engineering, Hindustan College of Engineering and Technology, Coimbatore. What is meant by rectifier? A rectifier is an electronic device that converts AC into DC using one or more PN junction diode. So it will convert the alternating current into direct current by using the normal PN junction diode. The diode will behave as a one-way valve that allows the current to flow in a single direction. So this process is known as rectification. So we are having two types of rectifiers, half-wave rectifier and full-wave rectifier. So first we will discuss about the half-wave rectifier. So the half-wave rectifier will use only one diode for the conversion. So it will allow only one half of the AC supply to be rectified and it will block the other half. So this is the half-wave rectifier circuit. So it will have a diode, a transformer and a resistive load. So the working of the half-wave rectifier, initially the high AC voltage is applied to the primary side of the step-down transformer. So since it is of step-down transformer, the voltage is stepped down to the required value and it will be available across the diode. So during positive half cycle of the AC voltage, the diode will be forward biased, and during negative half cycle of the AC voltage, the diode will be reverse biased. When the diode is forward biased, it will be acting as a closed switch. So it will allow the current to reach the load, so there will be the output voltage across the load. So when the diode is reverse biased, it will be acting as an open switch. So since the circuit is open, so no current flows through the circuit, so that the current will not reach to the load, so the output voltage will also be zero. So this is the waveform of the half-wave rectifier. So the first plot shows the input supply voltage, that is AC voltage. So the second plot shows the rectified output, that is DC output. So it is allowing only the positive half cycle to pass through it and it is blocking the negative half cycle. So this is the second type of the rectifier, this is full wave rectifier. So irrespective of the half cycles, so the full wave rectifier will convert both positive half cycle as well as negative half cycle into the DC output. So unlike half wave rectifier, so the half wave rectifier, we know that it will utilize only the half cycle of the actual full cycle. So since the half wave rectifier is actually converting only half of the input supply voltage, so it will have a lower efficiency when compared to the full wave rectifier. So there are two types of full wave rectifier. So the first type is center tap full wave rectifier and the second type is bridge rectifier. In center tap rectifier, we will be having a tapping transformer. So this AB is the secondary side of the tap changing transformer at the center point as C. So it will have two diodes, they have D1 and D2, it is shown in the circuit diagram. When the AC supply is switched on, so there will be a secondary voltage across the point A and B. So during positive half cycle of the secondary voltage, point A will be positive and point B will be negative. This will make the diode D1 to be forward biased, that is the current transfer from anode to cathode, and correspondingly the diode D2 to be reverse biased, so that the D1 will conduct during positive half cycle and at the same time D2 will not conduct. So during positive half cycle, the current direction starts from A through D1 and RL, it will reach to the C. That is, the current is traveling only in the upper part of the secondary winding. And during negative half cycle, the NB becomes positive and the NA becomes negative. The diode D2 will be forward biased and diode D1 will be reverse biased. Now the current flows from B through D2 RL, it will reach to C. In this case, the current is flowing only the second half of the secondary winding. So this is the waveform of the full wave rectifier. The first plot shows the AC voltage waveform, that is input voltage waveform. The second plot shows the output current. So unlike half wave rectifier, it is converting both the cycles, that is positive half cycle as well as negative half cycle. So we are getting a continuous pattern output. Correspondingly, the third plot shows the output voltage across the load. So it will be similar to that of the output current. So we are getting the voltage for both positive half cycle as well as the negative half cycle. So this is the second type of the full wave rectifier, full wave bridge rectifier. So unlike the center tapped full wave rectifier, we are going to have a normal transformer, the primary winding and secondary winding. The primary winding will be connected with the AC supply, and the secondary winding is connected with a bridge consisting of 4 diodes, diode D1, D2, D3 and D4. When the AC supply voltage is turned on, so there will be a voltage across the point A and B. So during positive half cycle, the end A becomes positive and the end B becomes negative. So under such circumstances, the diode D1 and D3 will be forward biased and the diode D2 and D4 will be reverse biased. Since we know that the diode will conduct only during the forward bias condition, so in this case D1 and D3 conducts, and at the same time the diode D2 and D4 will not conduct. Now the current starts from A through D1, RL, D3 and it will reach to B. So during negative half cycle, the point A becomes negative and B becomes positive. So in this case, it will forward bias the diode D2 and D4, and at the same time the diodes D1 and D3 will be reverse bias, so it won't conduct. So the diode D2 and D4 conducts here and D1 and D3 will not conduct. So now the current will start from the point B, it will flow through D2, RL, D4 and it will reach to the point A. So this is the operation of the rectifier, and we have seen about what is meant by rectifier, what are the types of rectifier, we have seen about the circuit diagram of the half wave rectifier and full wave rectifier, and that's all for today's class. Thank you.